All right, so the rest of the 5.6 lesson we're going to finish up today. And so just to review before we get to those last couple questions, yesterday we were talking about direct variations and this K value that all direct variations have. This K value is called the constant of proportionality, but you're not going to really hear me refer to it as that. What you're going to hear me refer to it as is the unit rate, which we divide to find unit rate, the slope, or y over x. And y over x, by the way, is rise over run, and so that's why it's also the slope value. And so we said that if you look at a direct variation on a graph, you're going to see that it forms a line, and that line goes through the origin. If you're looking at something that doesn't make a line, so it curves or it stops and goes a different direction, or it just doesn't go through the origin, then that's not a direct variation. And a direct variation is another way of saying a proportional relationship. If you're looking at a chart, like we did yesterday, it's really easy to tell because if they don't give you the graph, all you have to do is divide the y's and the x's and see if you get the same number each time. And if you do, not only is it a direct variation, but that number you keep getting is the K value. So for example, bless you, if I plot those points, of course, we couldn't plot 10, 60, but when I plot those points and draw the line, not only does the line go through the origin to prove that this is proportional, but I get the same number each time. I get 6. 6 is my K value. 6 is my unit rate, $6 per ticket. And the special thing that we had to do yesterday is we had to write the direct variation equation by replacing the K in y equals KX with, in this case, 6, because 6 was our K value. That number you keep getting every time you do the division. And so we wrote y equals 6x. That was really the only thing new that we did yesterday. We said that this was a direct variation because it goes through the origin. And no matter what point you're looking at on your line, if you divide 10 divided by 1, 30 divided by 3, 50 divided by 5, you're going to get 10 every time. And so that's a direct variation, and 10 is our K value. So y equals 10x. B was not a direct variation, didn't go through the origin. C didn't go through the origin, not a direct variation. D did go through the origin, but there was really only one good point we could use. And it was the one that gave us that nice intersection up here. And so we did 30 divided by 5. And we found out our K value was 6 for this problem as well. And so y equals 6x because $6 per pizza. And if you look, it actually does look like $6 for one pizza. So it's just hard to tell to be sure. So that's why we use this nice point here that gives us a nice answer. We want to make sure we're getting the correct answer. Then we looked at graphs, right? Or not graphs, charts, tables, whatever you want to call them. And if you graph them, sure, you can still look visually. I mean, you can see this is not a direct variation, for example, A, because it doesn't go through the origin. But if you do 4 divided by 4, or 2 divided by 3, or 0 divided by 2, or -2 divided by 1, you get different answers each time. There's no way this is proportional. Whereas if you look at this one, not only do we see that it does go through the origin, but 6 divided by 6, 4 divided by 4, 2 divided by 2, you get 1 every time, and that was our K value. There was one direct variation in this group, and it was example D, because you got the same K value of 4 every time you did y divided by x. So K value was 4, and so the equation was y equals 4x. Just because you don't see that it goes through the origin doesn't mean it actually does. It just means the points they give you were up here, and eventually it will go through the origin. But just because you don't see it doesn't necessarily mean what all you have to do is divide, and you can see, oh yeah, it is going to go through the origin because you get the same value each time. Then we left off with this robotic vacuum cleaner. Does anyone have a robotic vacuum cleaner at home? No. Did we have nobody in this class had one? I had my afternoon class, almost everybody raised their hand, which shocked me because I've never even thought about getting a robotic vacuum cleaner.
They're rich.
Yeah, they're expensive, aren't they? It's like, well, I can just get like a $40 vacuum cleaner and go and clean it a lot faster because it only cleans 16 square feet a minute. And so if you want to know how much a square foot is, the tiles on the floor are 1 square foot. So put 16 of them together. 16 would be like a 4x4 square, right? So think 4 tiles long, 4 tiles wide. So this little square right here, I'm standing at, okay, it takes it a minute to clean that. And so I can just take my vacuum and go and be done, right? In like 10 seconds, that could be done. So I don't think that's the sound they make, but. So we got 16 as our K value, 16 square feet a minute. And then we said our equation would be y equals 16x. Okay, So we said, is the graph a line? Yes, it does make a line. Does it go through the origin? Yes. But the thing is, I don't actually need the graph to be able to tell if it's proportional. I just need you to give me some points. And if I do y divided by x, I'm going to get 16 every time. Now, I don't know if we did this in this particular class yesterday. Maybe we did. But we know 32 divided by 2 gives us 16, and 16 divided by 1. Instead of using fractions, we ended up using decimals to get the other 16s. So like 8 divided by a half is the same as 8 divided by what decimal? What decimal is a half? 0.5. So using my calculator, I just do 8 divided by 0.5, and that gives me 16. So you don't have to use your fraction rules, but if you do, 8 divided by a half is the same as 8 times its reciprocal. What's the reciprocal of 1/2? 2/1, which is just 2. So 8 times 2 is the same, and that gives us the 16. And same with the 3/2. You could use 1.5 or 1.5. Okay, so a couple questions left, and we saw like if you looked in the homework, you would have seen a couple like this. Okay, it says the variables x and y vary directly, which means they will make a direct variation. They will be proportional. Use the values to find the constant of proportionality, which is k. They're wanting you to find k. Then write the equation that relates x to y, which is the direct variation equation. Okay, these problems tend to confuse everybody, but we've already done problems like this. Go back to the vacuum problem. How did we find k? We divided. Which number did we divide first? Y, or 16, yeah, divided by 1, right? Y divided by x, okay? They gave us 4 points here. All of them gave us the same answer because it's a proportional relationship. They're all going to be the same. Well, in this problem, they've given us 1 point. When x is 3, y is 72. Well, I don't need a bunch of points because the instructions said that there's going to be a k value. And to find k, I have to do y divided by x. So all I need you to do to find k is tell me what 72 divided by 3 is. Y divided by x. 24. So our k value is 24. You're doing the same thing, except instead of doing it 4 times, you're only doing it once. Because I don't need you to prove to me that it's the same. That's why we did it 4 times. I needed to see if it was the same every time. Here, I don't need to do it 4 times because the instructions already say that they vary directly. It's going to be a direct variation. So I only need to check once. Our k value is 24. And if our k value is 24, our direct variation equation is going to be y equals 24x. Yeah. So it's not a hard, in fact, I think it's an easier problem because you only have to do the division once instead of 4 times. So example B. K is y divided by x. So what numbers am I dividing? 5 divided by 15. What is 5 divided by 15? No, you did 15. You did 15 divided by 5. So we got to be careful that we do y divided by x. 5 divided by 15 is 0.3 repeating. And what is 0.3 repeating as a fraction? Do you remember? We talked about this earlier this unit. We talked about 0.3, we talked about 0.6 repeating and 0.3 repeating. 0.3 repeating is 1/3. You know another way you could get 1/3? When we write 5 divided by 15, we've obviously just turned that into a fraction. And guess what 5 divided by 15 reduces to? 1/3. Yeah, so you'll get 1/3 for k if you just reduce your fraction.
I remember you had us write that down.
We wrote it down in one of the notes somewhere. Yeah, it'll come back up later again. This even the next next semester it'll come back up. So we should hopefully get more familiar with it. So our k value is 1/3. Okay. So finish it. Y equals 1/3 x. Yep. Every time we find our k value, we're gonna want to write to the equation just by taking that k and plugging it in. Right there. So y equals 1/3 x. Last one was y equals 24x. So yeah, once you find your k value, you just have to write it in there. Okay, good.
Yeah.
Okay, we're gonna continue working with the value as we move into tonight's 5.2 extension homework.